Hey class, today we're going to talk about the metric system. Hopefully you've had time to review your notes. It's fairly simple. A lot of teachers in the past have taught you, hey, you can multiply, you can divide by tens, hundreds, thousands. I'm going to show you a shortcut. We know that here we got basic units, okay? And in those basic units, let's talk about those for a second. I have grams, I have meters, and I have liters. I know if I'm measuring grams, that should be some sort of mass that I'm looking at. If I'm measuring meters, that's just a distance from point A to point B. And if I'm measuring liters, that's when I'm getting into volume. There should be some sort of liquid or gas involved in it. Okay? All these basic units are going to go right here. Everything in the metric system is based off those three basic units. Then there's a prefix that goes along with it. So let's talk about those for a second. So obviously the big guy on the totem pole is going to be kilo. We know that's a unit of measurement. Then we know there's hecto. Then we know there's deca. And if you notice, all three of these steps have a capital letter. So that means they're all above everything else. Now down here is when we get into the smaller units. I got deci, centi, and I got milli. Okay? So milli's the little bitty guy down there, and he's the one that has the real teeny tiny measurements. But one of the reasons physics likes to use these measurements is because these are the ones that are large enough to put your hands on, touch, see, feel, and really dive into. But everything is going to have a gram, a meter, or a liter attached to it, depending on what I'm measuring. Most of the time in physics, this meters is what we worry about. It's either meters or it's in grams, but since physics is a macro, okay, that means large science, we're going to use kilograms, okay? Because it takes a lot of kilograms for me to get into the mass, and I'm going to need that when I start calculating newtons and forces and different things. So let's just talk about one real quick, and I'm going to show you the conversion process. But while I'm thinking about it, draw you an arrow, and if I'm going down the steps, okay, going down the steps, I move decimal to the right, okay? Okay, so if I'm looking this way, if I'm going up the ladder, I move it to the left. If I go down the ladder, I move it to the right, okay? So accompany with another arrow on the other side. And I should see this on all your physics stuff, because this is going to help you, because there's going to get a lot of formulas that we're going to have to convert things into, and this is the simplest format to convert quickly without having to do a lot of multiplying and dividing. So if I'm going up the ladder, I simply move my decimal to the left. Okay? Down to the right, up to the left. Okay? You're going to see my hands differently, so pay attention. I'm going up, it's my left hand. I'm going down, it's my right hand. Okay? That's the simplest. So now let's do a couple here. If I have 1 centimeter, how many meters is that going to be? Well, look, you always start on the step you're at, and then you count how many steps you go to get to that point. So it's 1, 2. Right? I'm going up, so I move it to the left. So my decimal's there. I go 1, 2. There goes my decimal. So I should have 0.01 meters. Everybody get that? Going up the ladder, move the decimal. There's an imaginary decimal here. It goes 1, 2, because I went up 2 steps. Let's go the other way. If I have 1 kilogram, how many grams would that equal? Well, think about it. I have to start here. 1, 2, 3. So I'm going 3 steps down. So that's my right. So now I take in 1, 2, 3. So I should end up with 1,000 grams. 1,000 grams is equal to 1 kilogram. That's the simplest way to remember how to do the conversions and to do them quickly, is this stair-step ladder. I hope you get some use out of it, and we'll be looking at it a lot more throughout this year.